Welcome everyone to our talk on the Infinite Hotel, scaling multi-tenant platforms through a unified API. Let's first, of course, introduce ourselves. So I am Carlos Mestre del Pino. I'm a KCD organizer in the Netherlands, and I'm going to use the moment to say we have a KCD coming up on the 3rd of July in Utrecht in the Netherlands, of course. I'm also a cloud solution architect in Microsoft, where I help Azure customers with getting up to speed with Kubernetes, scaling a little bit their platform operations. And yeah, you got there. I'm Mestre del Pino on most, no, I believe in all socials. And of course, you got the QR there if you want to visit any of my links.
Yeah, hello everybody. I'm Chris. I'm working in Upbound as software engineer, taking care of developer experience for Crossplane. And yes, Crossplane is our popular open source project. And with Upbound, we built an enterprise software around obviously Crossplane, right? And we really leveraging Crossplane here and going with the control planes on scale.
So yeah, first just a small disclaimer, because we've been using some supporting materials from this YouTube video, which is the Infinite Hotel Paradox. We will be talking a little bit about it now, and well, this is the kind of like inspiration that we got. We're just using some of the images from there. The alternative was to like do some ChatGPT generated Studio Ghibli images, which are very on the topics today. But yeah, because I discovered this paradox through this video, I wanted to give a bit of credit as well to, yeah, well, to Ted and to Jeff Dekowski. And please, there's a link as well in there if you ever are curious about the rest of the paradox. So just to set the scene a little bit, I'm going to give a bit of an introduction on the Infinite Hotel Paradox, or also known as the Hilbert Paradox of the Grand Hotel. It was created by David Hilbert on 1925 lecture. It was the first introduced. And it demonstrates how a hotel with infinite capacity, that it's full, might still be able to accommodate some guests. It was made for humans to try to wrap our heads around the concept of infinity, given that humans are very, very bad with extremely large numbers. And well, in this situation, there's a hotel, like I said, it's infinite. It has infinite rooms, it's full. And there is a hotel manager which uses math to solve problems and be able to accommodate more guests. To give a bit more context before moving on to our infinite hotel, this is just a couple of the scenarios that we see. So say that you have the hotel with infinite rooms and it's entirely full. How do we accommodate one new guest? Well, in this case, the hotel manager would just ask all the guests to move to the room n+1. So if the guest in the first room will move to the second, the one in the second moves to the third, and so on, which vacates the first room. Then it goes a little bit deeper. So what would happen if now we are receiving an infinite amount of guests? Well, the hotel manager, once again, with his math knowledge, says, OK, let's just take everyone to the room 2n. What that means is that the person in the first room will go to the room 2, the one on the 2 to the 4th, and so on. What that does is that it vacates all the uneven number rooms, which, of course, there are an infinite amount of them, and therefore we can host an infinite amount of guests. Goes a little bit deeper into deeper mathematical concepts, which I will not go too much into because that's not what we came here to talk about. But it also talks about the scenario in which you might have infinite ferries, each of them containing an infinite amount of buses, and each of these buses containing an infinite amount of people. So it's kind of going deeper on the levels of infinity, kind of nested, which is as well the way that we're building our platform sometimes. So with all of this said, we need to, well, I'm going to give you some of the, let's say, what you call the setup for our infinite hotel, which we will be also talking about, well, demonstrating a little bit later. So Of course, we are trying to provide infinite capacity in the hotel, and now we are talking about cloud resources, so that's why we're quoting the infinite. We cannot be as vast, let's say, as if we were just talking about mathematical concepts. We also have our hotel manager, which in our case, it's our control plane. It's quite important to mention, even before, based on the paradox, it's not only about having the infinite capacity, but it's also about having someone who has the knowledge of, in this case, in that case, mathematics, so that they can accommodate. And in our case, our hotel manager is using platform engineering principles to scale infinitely. So now let me talk a bit of what would we need in such infinite hotel. So, of course, first thing that we will need is an infinite amount of lobbies or buildings which will be able to host our infinite amount of floors. And then in our floors, we will be putting our rooms, which can finally, of course, accommodate the guests. But as any other good hotel, we're not only providing the rooms, we're not only providing infrastructure, but we're also providing some supporting services. And in our case, we have a gate guard, or any infinite amount of them, to ensure that guests are only allowed in their respective rooms, right? So that they are not able to get into someone else's room. We also have a concierge service, or any infinite amount of them, which will bring the guests' belongings into their rooms. So how are we defining this? Is, of course, as Kubernetes custom resource definitions, or in our case, with cross-plane compositions and composite resource definitions. That allows us, of course, to define everything, everything with YAML and with some functions. And now I just want to show you some of the things that we define. So, for example, for the lobby, we have it very basic at the moment. The lobby will represent a network, a VNet. All of this is deployed in Azure, so that, of course, maps to the VNet. And then we are just setting something in here, so like what wing it's on. In our case, we chose West US. We're trying to scale up infinitely, so we wouldn't be using Azure West Europe. Then, after we have our lobbies, we are able to build our floors on top of that. Our floors will be, or each floor will be an AKS cluster and some supporting services, which we will show later a bit more in detail. Some of the parameters that we're setting in here, so we're setting what lobby the floor is related to, so on top of what lobby it should be built. This is, of course, the network for your AKS cluster. You can also see that we also have the wing there in the region, but that's also something that could be directly inherited from the lobby, and we have some more examples of how that happens later. And a few more things like the occupancy permit, which in our case is the Kubernetes version, or the AKS version for the AKS cluster. And we have as well something related to the sizing of our floor, which we have a count, so for number of nodes. And we also have our room class, in this case basic suite, which will map to different VM sizes. We then have our rooms, where we can finally start accommodating our guests. And as well, we decided to leave it simple right now for this use case, for this demo. And of course, we're just saying in what floor we would like our room to be. You could also add some other parameters related to the sizing. In our case, the room, it's a loft vCluster, which gets deployed onto an AKS cluster. So of course, that goes on a given namespace. So if you wanted to do anything related to sizing of your rooms, you could use resource quota, you could use limit ranges. So that would be a way as well how you could limit the size of your rooms. Next to the infrastructure, of course, we have the services, and we will have a gate guard as well, which in our case is Keycloak, and it will be, of course, providing the access into the rooms as well as providing the access to the concierge service. In here, we're only setting up the lobby, so we have a one-to-one relation at the moment with gate guards and lobbies. And of course, we will give it a name as well, which will relate to the ingress that will be created for that keycloak instance. Next, we have our concierge, which is Argo CD. Of course, the concierge is there to take the guest belongings into the room. And as well, similar to the setup on the gate guard, right now we're just saying on what lobby our concierge is operating, and as well a name for it so that it can be accessible from outside. And of course, a hotel wouldn't be anything without their guests. So we also have a resource definition for the guests. And some of the things that we're setting in here, of course, again, on what lobby. We are not currently limiting per room, so a user may be able to use a different number of rooms in the way that you might use different clusters of different environments. In here, we will set things like, of course, information about the user. So what's the username, last name, first name, an email. We'll set up a group, which will map to the OIDC groups provided by Keycloak. And of course, we will have an initial password, which, or we need to make a reference to initial password, which is just on a Kubernetes secret. So how does all of this piece together? I will first show you. I will first show you a little bit about our hotel manager, and then I will move on to the architecture of our hotel. So this is our hotel manager, which, as I said, is one of the most important elements in the setup. Without the hotel's manager, let's say, platform engineering knowledge and capabilities, we would not be able to manage our hotel. So the components in our hotel manager, we have, of course, a crossplane deployed into there, and then we have as well the providers and provider configs. We are currently, or for the demo, we are currently hosting it in an Upbound control plane, but you could deploy this into an AKS cluster as well. In here we have our controllers, so those are the providers, so that we will be able to create resources outside of Kubernetes with crossplane. And we have one for Keycloak, of course, Azure, and then we'll also be deploying both Kubernetes resources, bare ones, and through Helm charts. We then, of course, need to provide the access to those APIs, which we're doing with the provider configs. And this is the way that we have it set up right now. Of course, it could be more flexible, but in any case, for the first one, with the Keycloak, well, for each Keycloak instance, or for each gate guard, we will have a provider config. Then we will also have an Azure provider config per subscription, because that's the way that the provider is working. And then per floor, so per AKS cluster, we will be configuring a provider config for both Kubernetes or Helm. Now, this is because we are not currently deploying any Helm chart or other resources as such into the rooms, but that's, of course, something that you could also do, or you could have, of course, both, because you might need to manage resources on both the AKS cluster and the virtual clusters. In terms of our hotel architecture, you can first see that we have our lobby. Oh, it's a little bit zoomed in, but we have our lobby perimeter, which is, of course, our VNet. We're then placing our AKS cluster in the VNet, as well as the supporting resources, which you can see in the top left. That's an NGINX ingress controller to provide the ingress into the Argo CD and Keycloak instances, as well as for the rooms, so the virtual clusters. That is integrated with Cert Manager and a cluster issuer using Let's Encrypt, so that we can create SSL certificates based on our domain name and inject them, let's say, at the ingress level. Then, of course, we have our room, so that's the V cluster in there. And we also have our gate guard and concierge. They're currently deployed in the same floor. If you had a different setup that you're not mapping to one floor, you could have that as well on a separate kind of like shared services cluster. So with that said, we now have our guest, which can give their belongings to the concierge, and they can also go through the gate guard in order to access their rooms. There's also another icon in there of a server, someone in the hotel, which is providing the room service, let's say. And what we're doing in here is creating certain service or Kubernetes deployment and service onto the host cluster and allowing it through to the V cluster. So that's our room service. In our case, our guest ordered a paella, and I hope they really like it because it's going to be an infinitely large one. Yeah.
So now it's me. Okay. I'm working with crossplane and infrastructure since years, right? And I want to give some nice input what I learned in environments, right? If you really want to build like an infinite platform with like you're scaling a lot of virtual clusters, you're scaling Kubernetes clusters, and what are the challenges, right? So at the end of the day, what you really want to do with the scaling of the platforms is you have multiple layers, which are really interesting here. So security, the management of all this kind of components, and something like your service architecture at the end of the day. So how many controllers from what you want to host on which layer of this platform, right? And in a bit we will unpack like all of these aspects here and talking a little bit about this. So again, a vision when you're building this kind of platforms is something like you want to be modular, you want to be like multi-tenant, you want to be running like multi-control planes baked by crossplane, for example. And the thing what you're trying to do is you want to unify like your infrastructure deployment, but also the application deployment inside your infrastructure. And then what you need to do is, if you want to achieve this vision, we have a lot of challenges, as I said, right? So we have the security and workload isolation topic to solve. We have scaling challenges. We have shared versus centralized service scaling. And we have something like service to infrastructure mappings when we're building this kind of infrastructure, right? So first thing would be security, right? And security and keeping workloads isolated can be really, really complicated fast in your platforms, right? Because if you want to leverage multi-tenants in your platforms, you need to isolate this tenant somehow, right? Perhaps the easiest part is like network isolation, so you're switching on some network isolation features. But thinking about if it comes to crossplane, right? Crossplane has today like provider configs that you can interact with other APIs with your cloud providers, and this provider configs are cluster scoped. So if you have multi-tenants now running on the same control plane, same cluster with crossplane, what you want to do. What I'm seeing as a pitfall in a lot of environments is something like the platform teams allowing their consumers to set as an input parameter the provider config, but that means like everybody can consume all your provider configs. And it's the same thing if it comes to something like connection secrets, right? If you're spinning up a Kubernetes cluster per default, right? You're getting cluster admin connection secret back. And if people are allowed to use all your provider configs, then you will see that tenant isolation is not really working anymore because I can grab it and can start rolling out some things on top of it, right? That said, the other thing is around what we're seeing relatively often is people then starting to think of isolation with our rooms here in the hotel is like, cool, we're spinning up like vCluster in the Kubernetes cluster, so we have more isolation, but this also leads then to more crossplane installations, more providers, more something, and you can also miss up like a lot of configurations in the vCluster if you're not setting the right settings for the network isolation, for example. Then it's perhaps like your workload is isolated, but under the hood you can like connect between each others from the controller perspective. The next thing would be if we're talking about scaling, right? And at the end of the day, scaling isn't magic, right? It's your architecture at the end of the day, right? So when we're talking about these scaling challenges, we need to also look at like 3 key areas. So if it comes to control planes, you need for scaling, right? You need to ensure your centralized components handle increased load, right? What does it mean if you're now running hundreds of crossplanes, hundreds of providers, hundreds of vCluster services, right? So under the hood, you can scale relatively easy with putting in more resources and so on. But on top of it, what you need to configure now on the individual services, right? And that's like relatively hard to do. The other thing is management overhead, right? So if you have now thousands of containers running, then your platform team perhaps has a lot of things to do to taking care of individual versions, taking care of all of this kind of providers, right? And the other thing is state management across clusters. What I'm seeing relatively often is that people spinning up like workloads from one of the other cluster, and if the control loops are not working great, right, then you have state here and state there, but they're not connected anymore, and you need to like figuring out what does this mean at the end of the day. So the next thing would be shared was the centralized service scaling. So it was interesting when we built up this demo here. Carlos asked me like, Chris, why we have only one concierge Argo CD deployed now? I would expect we have this in every room. Everybody gets his own Argo CD. And then I asked like, okay, do you also want to like deploy now everyone a key cloak in the room? Yeah. Or what is the idea, right? And what you really need to figure out then is like you need to mapping your services to your right infrastructure, and you need to figure out what all kind of things, what you try to build, right? Because these are technical details, but you have strategic decisions perhaps at the end of the day in your company, and how many of these controllers you really want to host. And if you have in the company the idea of we want to have a centralized one, then the platform team needs to figure out what it means, right? So you need to do something like pilot deployments from this infrastructure components, right? You need to figure out like how is the behavior in your controlled environment. Like the other thing is like load testing. So you need to simulate real-world conditions. What we're seeing relatively often is that people like running crossplane, and then with like hundreds of resources, everything is fine, but with thousands of resources and a lot of more controllers, they have like problems that they can run this. The other thing is you need to figure out like all this kind of things. So what is your high availability? What is your performance? And what is at the end of the day your quick recovery after a failure, right? Can you spin up something in parallel new? Do you need to configure like state migrations between? All this kind of things you need to figure out if you're running this kind of platforms. The other thing here is, again, service to infrastructure mapping. So, for example, we talked about when you're having a key cloak and you're having an Argo CD and you want to have now configurations for OIDC that people from your infrastructure can log into your Argo CD, right? How you configure this with the key cloak side, everything, or do you allowing like self-service? And if you're allowing self-service, does this mean everybody can reach your key cloak and doing some configuration changes in your key cloak? So you need to figure out a way to stop configuring everything in your key cloak, and that's like really important. And I would like really happy to chat with some folks how you like limiting the access to this kind of APIs, right? If you're running in this kind of multi-cluster environments. And then the other thing is like, as I said before, number of instances, but also like it really depends on how many distribution you're running of your services. You need to understand your load characteristics again, your replication needs, all this kind of ideas you need to figure out. And then, if this strategic, if you're matching like all this kind of things for today in your platform, right? And you're figuring out like all this kind of things I was talking about, then you also be very well prepared for the future, or if you have unexpected loads on this platform. That said, at the end of the day, it's all about scaling challenges, and if they come down, it's all about like strong API design if you're building the platform, right? So if your APIs needs to be designed for like flexibility, for composability, and for like clear contracts, means if you're building like an Argo CD today, right, what is your contract? Deploying it to a Kubernetes API, and then it doesn't matter if it's like in AWS, EKS cluster, an Azure cluster, in V cluster, whatever, right? And you can scale whatever this means, right? And yeah, and then scaling becomes your architectural choice and rather than an afterthought. And it's the groundwork of your platform if you're doing the things right and thinking about like all the scaling things. Cool. I think we have like 4 minutes left. Let me try. Sorry. What's now? The entire screen. So I want to share like one thing if it comes to like cross-plane projects, and I want to like highlight what I'm seeing in a lot of cross-plane setups. So if you're creating like all your APIs and pushing it to an OCI registry, you can relatively easy like get automatic API documentations, right? But a lot of people like creating their APIs without descriptions, without input validations, without nothing, right? Then you see something like this. So you have no idea what is a gate guard, what is a lobby, what is the name. There's no description, no nothing, right? So if you're building platforms for infinite scale, please, guys, starting to document using the API server for automatic validation from your input with CAL, with enum support, all this kind of stuff, right? Because if you're not doing this right, then you cannot scale for infinity because like you need to like help all your customers to like onboard on this platform, right? The other thing is, yeah, I think you can see this. The other thing is what I relatively often seeing that people like installing like something like this. So all versions bigger than like 000 means like at the end of the day latest. If you're installing latest means you have like one cluster here in this version and the other cluster here in this version, and in your V cluster setup another version. So please use like a specific version and then use something like Runaway to update all your components here. The next thing what I relatively often see if people are building this kind of platforms, they have mono repositories, so everything is together versioned, relatively bad. So as an example here, you see our full hotel here is in a mono repository. Everything gets a version number together, and then it's relatively hard to only like updating like a specific service here. The other thing is what I'm seeing is in this example, you're seeing tests here. So we're having here composition tests, but we don't see some kind of end-to-end tests, right? And for example, I was reading like a blog post from Grafana the last days. Without end-to-end test, you can relatively easy like mess up, for example, a Kubernetes service, deprovision in load balancer, and then you're fucked, right? Because you need to figure out then how I can get the load balancers back, how I get the services back, and all this kind of stuff. So please, like running end-to-end tests here. The other things which are relatively interesting here, if you're going a little bit deeper in the codes, I'm seeing relatively often that people using a lot of hard-coded stuff. So something like this, crossplane IO / claim names, it's fine. If you're running like a single tenant to use claim names, right? But if you have multiple tenants, you have claims in multiple namespaces, but at the end on the cluster level, it's the same name. So you have name clashes. You're perhaps giving like resources to other tenants in your platform. That's like relatively bad. Yeah, and all kind of this stuff we have a Git repository open. We're sharing this here, so you can have a look afterwards. So we have a lot of things here which is bad under the hood, but you can start with it and like enhancing this. But if you're running this directly today, you will never like get an infinite scale from your platform because there's a lot of open points inside. So then, yes, that's for you. 30 seconds.
Ooh, thank you very much. Well, I think I can wrap it up in 30 seconds. So we're just straight to the point with our key takeaways. So you must test your platform components, limits and scaling before finding out during operations. So again, this kind of reinforces a bit the planning, the design, right? And just like trying stuff out before you go and deploy it, because you do not want your platform to break and then you're going to have to fix it after in production. Then the architecture, as Chris well mentioned, does not only solve technical challenges, but also strategical and organizational. So it's very important to know the way that you're going to be distributing your instances, and are you giving something for a tenant, or is that being shared, right? So you do need to understand what you exactly need to achieve before going and deploying a platform like such. And of course, starting with the wrong decisions will make you firefight. So again, testing, testing, and testing. Thank you very much.